because today is our review day, I wanted to cover two topics that we kind of briefly touched upon, but to go a little bit more in depth with it. And so the first is this idea of quadratic transformations. We've done transformations in the past, but specifically with these kind of quadratics, I just wanted to review a little bit. So starting from our standard y equals x squared quadratic equation, make a formula, or make the equation that makes you move up 2, reflects you over the x-axis, moves left 5, and has a vertical stretch of 9. So I will give you a few moments to do so. Okay. Ethan, can you tell me one thing that we will need in our equation? Just one thing. We need an x plus 5. All right. Great. Kate, could you tell us another thing? All right. 9. Which side? Over here. We need a 9. All right. Let's see. Did you want to add one more? Or did you have a question? Yeah, you can add one. Right, we want a negative in front of the 9 because we reflected over the x-axis. All right, let's see. Lupe, could you add one more thing for us? There's a plus 2 at the end here. All right. Sam, could you add another thing? The little 2? Yeah. Okay, we want to square this. All right. And then let's see. Audrey, could you tell us the last thing for this equation? Just to complete our equation, what else do we need? Y equals, exactly. Right? It's not an equation if there's no equal sign. Okay? Are we okay? All right. So, from this quadratic transformations, are we solid on this, shaky on this, or lost on this? Solid, shaky, lost. Solid? Okay, cool. One other example, if I just kind of sketch a graph. These are just all intervals of 1. Okay. If I took this and I said, all right, I want some kind of vertical stretch in my form, in my equation, right? If I wanted a vertical stretch in my equation, and say I thought a good equation would be y equals negative x minus 4 squared plus 1. Right? If I had this, how would you sketch this? So take a few moments, sketch this graph. I'll give you a few moments to do so. We have our equation. From our equation, what is our vertex? What is the vertex from this equation? Tucker, what do you think?
Vertex?
Yes.
The vertex on this one would be
4, 1. All right. So our vertex is at 4, 1. Is our graph facing upwards or downwards? Downwards. All right. So what other piece of information might be helpful? We know it's facing downwards, right? what is our A coefficient in the front there? Do we have a vertical stretch? No. So it's just, if we go over 1, you go down 1. If you go over 1, you go down 1. And then we know it's downwards. Right? So you might be thinking, that was something that we learned day 1. What if, instead of saying just a negative x minus 4, what if this was a negative 1/3? How would that change your current graph? Take a few moments. Talk with the people around you. Would that make your graph thinner, thicker, wider, thinner? What would it make? Right? Okay. Show of hands. Who thinks that it's going to get thinner? Who thinks it's going to get fatter? Okay. Most people are just like, I have no idea. Right? Let's go over it then. Okay? So, if we had, say for instance, instead of making this a 1/3, we just had a 3, like we normally do, right? So if this was just a 3 instead, from this point here, what would I do in order to achieve that 3, the vertical stretch of 3? You go over 1, and then you go down 3, right? 1, 2, 3. And so this is your next point here. So then that would be your graph. Did that get thinner or fatter? That got thinner, right? But now we're dealing with a fraction. Because we're dealing with a fraction now, if we start from this same point and you go over 1, how far down are you going? Just a 1/3, right? It's just like this little tiny part here, okay? So you're just going over, down a 1/3. So your graph is going to look more like this. Would going over 1 and down a 1/3 be the same thing as if I went over 3 and down 1? It would not be the same thing. Notice that your parabola doesn't match up with this point, okay? Your parabola is not matching up because that is not how we're looking at the stretch. We're looking at the stretch as just over 1. Only looking at over 1. How far down or up are you going? Okay? So this is not what we want to do. Okay. From here, I have a short activity I think you will benefit from, and it's basically looking at graphs, looking at our 3 different forms that we've been looking at for this past week. Okay? It is a Desmos activity, so if you could get onto student.desmos.com. I will pull this up. So if you go onto student.desmos.com and you type in this class code, you'll be able to access the activity. It's pretty short. It's only 4 slides, but I think it's helped a lot of people. Okay? Helps a little bit with misconceptions. So we'll spend the next 10 or so minutes working on this, and then we'll go over it briefly just to make sure we're all on the same page, and then we'll have the rest of the period to work on our review sheet and on the homework for tonight. Okay? So one quick thing about the Desmos. There are some terms that are slightly different than terms that we're normally used to, so I just wanted to go over them. On the first slide, you see that they're talking about something called Intercept Form. If you think about Intercept Form, which of our 3 forms focuses on the intercepts? The factored form. So they're just synonymous. It's just how other people typically call this form. let's see, what was the other? Thank you. So you might see standard form. What form do you think that corresponds to? That's just our general form. General, standard, very similar. And the last thing that you won't see until the third page, I believe, is something about concave. It mentions this word concave. Okay? All that means is what direction is your parabola facing? If it's facing upwards, it's making a U, then it's concave up. See, U for up. Yes. And then if it's facing downwards, it's kind of like a hill or a mountain, then it's concave down. Okay? Let me know if there are other terms on there that are confusing or that you aren't familiar with, so we can address those. All right? You now have about 10, 15 minutes. Work on this a little bit. All right? If you finish this up and we're waiting for other people to finish, you can start the homework. All right? But I would definitely advise you to start this first. Okay, I will pause while you get started with the activity. So we are looking at the last slide of the Desmos activity that we just did. We want to go over a standard form example, and we want to go over a factored form example with matching these graphs. So of the three, I believe there were 3 different standard forms on here, correct? Of the 3 standard forms, which one was hardest for people? Or which one would you like to go over? Is it the one that ends in 25, the one that ends in 2, or the one that ends in -3? Which one would you like to go over? The -3? Okay, if we're looking at this -3 one, the reason why I placed emphasis on the -3, what is -3? It's our y-intercept. If it's our y-intercept, that means that we have a negative y-intercept. So if we look at all of the graphs we have here, of these graphs, which one has a negative y-intercept? Looks like this one does here. It looks like this one does here. And I think there's one more. All the way over here. So these 3, I don't want this. These 3 graphs are x-intercepts, or have negative x-intercepts, all right? But now we have to choose, oh, there we go. Now we have to choose of those, which one fits -3? What other information do we know about this one? What's the first thing after the y equals? There's a negative. So what direction is our parabola going? It's going downwards, right? So if it's going downwards, which of our 3 examples here go downward? First one, second one, or third one? Which parabola goes down? First one, second one, or third? First one. So that means that this will just go with the first one. So you look at the y-intercepts there, but we're also looking at, oh, there's a negative. So those have to correspond, right? All right, let's look at a factored one. Let's see. How about this one here? If we have a factored form and it's y equals x minus 1 times x plus 5, what do we know about this? Our x-intercepts. So our x-intercepts, if it's in a parenthesis, do you trust the sign or not? You don't trust it, right? So if you don't trust it, that means that this is a +1 and a -5 for our x-intercepts. So now we have to look at our graphs and say, okay, which of our graphs has a +1 and a -5? Those are both negative, so probably not that one. Does this one even have roots? No, so it's not that one. What about this one? Does that one have roots? Yeah, but it's just got like 1, right? So probably not that one. What about this one? It's got a -1 and a +5. Is that what we want? Do we want a -1 and a +5? No, we want a +1 and a -5. So how about this one? That one looks good. All right, so then we match those up. Okay. So that's kind of the thought process I have when I'm solving these, is just what's the important information? How can I find it? How does it relate to these graphs? Okay. Just something quick about this one. Did everyone get that if it says there's an axis of symmetry at 4, that means that you're going along this line? That means that your vertex has to have a positive 4. So if you looked at this one here and this one here and saw, oh, it's inside of parentheses, those are x equals -4, you realize that these don't work. And then did you notice that if it's concave down, that's another way of saying our parabola is going downwards like this, which means it has to be negative, which means this one doesn't work because it's positive. Okay. Great. The rest of the time you have, about 12 minutes, continue working on your review. Try and get, I bet you guys could get that done and the quiz done. But you could, all right? And do you have a question about this? Okay, then I'm just gonna, did you have a question about this? Okay, then I'm just going to end this, and that is all we have for today.